Hi everyone, today I will show you which record insertion causes the change in the depth of a B+tree index. This video is based on the blog, B+tree index structure in InnoDB, written by Jeremy Cole in 2013. Jeremy Cole is the 14th employee of MySQL AB, a Swedish startup database company. Before testing, check the operating system version and MySQL version, and check the value of the variable InnoDB_page_size. In this test, the value of the variable InnoDB_page_size is 16 kilobytes. I did not specify a value, so the instance was initialized with the default page size. I created a table called T_tree for this test, which has two columns, one called I of type int and auto_increment, and another called S of type varchar. I changed the values of two variables, InnoDB_max_dirty_pages_pct_lwm equals 0 and InnoDB_max_dirty_pages_pct equals 0. When the values of these two variables are set to 0, each inserted SQL statement immediately flushes the buffer data to the disk file. First, we use InnoDB_space to view the id file space index information of the table T_tree we just created. The B+tree index depth for this table is 0. This index comes from the primary key of the T_tree table, the column is called I. I wrote a script for this test. This script checks the index depth of the table for each record inserted and prints the total number of records in the table and the index depth of the table. If the depth is equal to 1, the script will break and exit. After inserting the 40th record, the result shows level 1, and the script is interrupted and exited. At this time, using this SQL statement, one page can contain 40-1 is equal to 39 records. Let's use the InnoDB_space program to get the T_tree.id index summary information. Now the index depth is 1. By reading Jeremy Cole's blog, we can know that a B+tree index of a simple table in InnoDB can store 1203 records per non-leaf page, so the number of records that a table with an index height equal to 2 can store will be less than 1203 times 39 is equal to 46,917. In order to reduce the insertion time, we use the insert into select method to insert records. When the maximum number of records is close to 46917, we change to the script method to insert one record at a time and observe whether the index height changes. Now it is 46,860. We exit the MySQL client connection and check the index summary of the T_tree.ibd file. The index height is still 1. We switch to the script that continues to insert the table. Before switching to the insert script, we can see that the logic of this script is like this. When the index height is equal to 2, the script will interrupt and exit. After a series of insert operations, when the 46,898th row is inserted, the depth of the index changes, so when the index height is equal to 2, the maximum number of records contained in the table is 46,898 minus 1 is equal to 46,897 rows. The image information is obtained through this test and speculation. Thank you for watching, see you next time.